Okay, so in the preceding video we learned about the direct comparison test. However, in this video we're going to learn about the limit comparison test. And the conditions for the limit comparison test are, so suppose we have a series a sub n that is greater than 0, and also a series b sub n that 2 is greater than 0 for all n greater than or equal to, just say, some positive integer n, capital N. So if this is the case, then we say that the limit as n goes to infinity of a sub n over b sub n equals some constant c, then we know that they both do the same thing. Meaning that if, say, a sub n diverges, and we know that, however we don't know what b sub n is, if we get some constant c, then that means b sub n also diverges. So, for the sake of an example, say we have an infinite series from n equals 1 to infinity of 2 over n cubed minus 4. And let's call this a sub n. So normally when you're looking for something to compare to in any of these comparison tests, you want to try to find the highest power and then base it off of that. So we can kind of disregard the 2 because you know from the p-series that the numerator doesn't necessarily matter as much as having a exponent in the denominator that is greater than 1 in order to converge. So let's call this b sub n. Now we know again that this is a convergence series by the p-series test. So following the test, we take the limit as n goes to infinity of a sub n 2 over n cubed minus 4 divided by 1 over n cubed. Now, using your algebra knowledge, we can flip the denominator and then combine to get this into 2n cubed divided by n cubed over n cubed minus 4. So, there's a few ways you could do this limit, but I chose to use to divide each term by the n behavior model, which is n cubed. So we know here these cancel, so on top it just becomes a 2, and then at the bottom, if we divide each term by n cubed right here, we get 1 minus 4 over n cubed. Now, if we just take the limit of this as n approaches infinity, we simply get, well, we know a very large number in the bottom cubed is a very large number still. 4 divided by a very large number is simply 0. 1 minus 0 is 1. 2 divided by 1 is simply 2. So, the limit as n goes to infinity is simply 2, which evidently is a constant as stated up here, the c value. So, c in this case equals 2, which does fit the conditions of the test. So because 2 is both positive and finite number, both series do the same thing. So we know 1 over n cubed converges by p-series test. Therefore, by limit comparison test, 2 divided by n cubed minus 4 also converges. In the next video, we'll cover the integral test.